Welcome to the playlist of digital signal processing. In this video, I'm going to discuss important questions and solutions from module number 2. So, these kind of questions you can expect in your for your forthcoming university examination. So, first question, what is the region of convergence? Why it is importance? Importance of ROC. So, you need to explain the pinpoint answer. Region of convergence is a set of value of set for which the set transform summation convergence. Why ROC is required? It helps to identify whether the set transform exists or not. Also, another important thing is you can predict the stability. Also, helps to find the causality of the signals. That is the importance of ROC. So you can plot the ROC and you can explain. Okay. Whether the set transform exists or not, you can explain with the help of one of the examples. That is also one of the possibility. Another important question is find the set transform of x of n equal to u of n plus 3. Here you should know about the shifting. Signal shifting you should know. U of n plus 3 starts from minus 3 to infinity. You know that. Let us define x of n. X of n equal to 1 for n greater than or is equal to minus 3. Therefore, set of x of z can be computed using n is equal to minus 3 to infinity set to the power minus n. So apply the shifting. Therefore, m can be written as n plus 3. Therefore, n is equal to m minus 3 from the linear equation. Therefore, x of z can be written as set to the power 3, m is equal to 0 to infinity set to the power minus m. This is very simple. If you elaborate, you will be getting set cube by 1 minus 1 by z or set cube by 1 minus z to the power minus 1, where the magnitude of z greater than 1. So, the also you can represent the diagrammatic, better draw the diagram and represent so that you can convey the examiner in a convenient way. Another important question is find the set transform of x of n equal to 2 to the power n u of n minus 4. Here, u of n minus 4 begins from n is equal to 4. Correct? Therefore, x of z general formula you can apply n is equal to 4 to infinity 2 to the power n z to the power minus n. The factor will be 2 raised to 4. Put n is equal to 4, then z is equal to it becomes z is equal to minus 4. Correct? So the factors are 2 to the power 4, z to the power minus 4. So by elaborating 2 to the power and z to the power 4, I'll be taking outside n is equal to 0, 2 z minus 1 whole to the power n. I'm going to make a modification. So this is nothing but 16 z to the power minus 4 upon 1 minus 2 z to the power minus 1. So that is a simplified expression. Oh, fine. Other question is explain right-sided, left-sided and two-sided signals in set transform. So you can elaborate point wise. So if you want, you can draw the diagram also. For the right-sided signal, non-zero for n greater than or is equal to 0. Here, region of convergence set greater than or set greater than poles. Left-sided, it is non-zero for n less than or is equal to 1. That is a region of convergence, like a set less than pole. Two-sided, non-zero for both positive and negative, then is equal to ROC between two circles. You can elaborate with the help of diagram so that it will be more conveyable. State and explain the final value theorem of set transform. Better go for the proof also. So final value theorem, it states that is or initial value theorem, not final value theorem, x of 0, that means initial 0. If you want, you can put x of 0 plus also. Limit z tends to infinity x of z. So that is actually called the initial value theorem. State the final value theorem of set transform. Here, instead of x of 0, I'll be putting x of infinity. Limit z tends to 1, 1 minus z to the power minus 1 into x of z. That is called the final value theorem. You can compare with the Laplace transform. It is almost similar, but there are slight difference. Proof is better actually. If you study the proof, that would be better. There are some important questions from discrete Fourier transform. Why DFT preferred over DTFT? So the first point is DFT gives finite number of samples, which is more conveyable for computation, which can be computed using fast Fourier transform. That is what we prefer DFT. DFT is used in digital systems and DSP processors compared to DTFT. DTFT is continuous, which cannot be implemented in the hardware, where DFT is discrete. So it is very comfortable for implementing the hardware. These are the major reason why we prefer DFT over DTFT. What is the difference between linear and circular convolution? One of the most important questions. Linear convolution, the output length can be computed by n plus m minus 1, where Circular convolution output length can be computed by using maximum of n comma m. It's a natural convolution where circular convolution is a periodic convolution. Another important difference. In case of linear convolution, it is applicable for linear time invariant system, where circular convolution used in both DFT and FFT. These are the few important difference between linear convolution and circular convolution. If you have ample of time, I request you to show with the help of one simple example, so that will give more weightage. What is the computational complexity of DFT? That means you can compare this expression, computational complexity. Okay. Similarly, DFT property. So study 6 DFT properties and state and prove linearity of DFT. So complete proof is not included. What you are supposed to do is, so you will be elaborating, the signal is given, then you will be applying the DFT. Therefore, y of n is becoming y of k, constant a is constant, that is no changes, x1 of n become x1 of k, x2 b no change, x2 of n become x2 of k. It is better you can elaborate principle of linearity. Explain the symmetry property of DFT for real sequence. So symmetry property states that if x of n is a real signal, therefore x of n minus k is equal to like x star of k. X of n is real and even, then x of k is real. X of n is real and odd, x of k is imaginary. This is actually called a symmetry property. You can elaborate with the help of either sine or cos function. So it will be very easy. So I request you to practice these kind of problems for your university examination. Find the circular convolution using the formula. Okay, x of n is given, h of n is given. So using this formula, you need to compute like a circular convolution. Okay, so these kind of problems you need to practice. The resultant you can verify the answer. Okay, you try to verify the answer. So find the 4-point DFT of the given signal. Okay, what you are supposed to do is you have to use the formula, right? Given formula you are supposed to use. X of n is given, so formula you can use. Okay, using this formula, you can easily compute x of 0, then you will be computing x of 1, x of 2, x of 3. Final answer will be x of k, you are able to get it. So kindly focus these answers. So these problems are very important. I think you will be getting the similar kind of problem in the university examination. Another problem is find the 4-point DFT of the given signal. Same method, x of 0, x of 1, x of 2, x of 3. So ultimately you will be getting this answer. You remember this formula. This formula is very important. You can make a note of this. Okay, this formula is very important. Similarly, another important question, finding out x of k by using the given signal. Given signal is given, you need to calculate x of k. So that is very important. Apart from that, I request you to solve the following problem. Set transform, find set transform of 3 to 3 raised to n u of n. Find set transform of x of n equal to u of n minus u of n minus y. You should know the concept of shifting. Set transform of x of n equal to cos pi n by 4 u of n. These problems are very important. Even calculate the 4-point DFT of 1, 2, 3, 4. Then calculate 8-point DFT of this particular signal. DFT using the matrix method. Okay, DFT property. Use circular shift property to find the DFT y of n equal to x of n minus 1. Prove the like a Parseval theorem with a suitable example. That is also another important question. Compute the circular convolution of these two signals. Then you should know the concept of zero padding to maintain the length equal. So these are the important problems which you can expect. If you found this video is useful, request you to share. If you need the similar kind of video, request you to subscribe our channel so that you will be getting similar kind of video. It is one of the best exam preparation strategy. You are able to get so many videos related to this particular thing. Also, kindly share this video. Don't forget to comment for the betterment. Kindly give your feedback. Happy learning. Wish you all the very best for your examination. Thank you.